Proceeding now with Mohammed's talk on crop yield response.
Hello everyone, I'm Mohammad Barik from Washington State University. I'm a postdoctoral research associate. So the title is about crop yield, but we are not there yet, and this talk is mostly about why we are doing this modeling study, mainly climate change and drought, how drought severity and frequency is changing to the climate change. So we are already, everyone is really specialized in drought by now. So in general terms, drought can be defined as deficiency of precipitation over an extended period, but it depends on what region we are looking at and how many, what kind of climatology we have, because deficiency of precipitation over some tropical region for 1 month is not the same as deficiency of precipitation in some Middle Eastern countries for 1 month. I'm going into the types of droughts. These are based on from the physical types of drought classification. They're mostly I classified. I placed only 4 of them. There are others like socio-economical droughts. I already talked about the meteorological drought. The hydrological drought is the deficiency of lower water storage in reservoir and lakes. Agricultural drought, whenever there is not enough soil moisture in the soil to grow crops, is considered as agricultural drought. And the snowpack drought, wherever there is not enough mountain snowpack, that's known as the snowpack drought, and that is what we are observing this year in the Pacific Northwest. So impacts of the Pacific Northwest drought in 2015, there are impacts in a lot of sectors, and WSDA calculated that, this is a rough estimation, about 1.2 billion of economical loss from agriculture. There are increasing wildfire that has been noticed this year, and also impact on fish and wildlife and on the recreation. There is the NDVI Greenness Index for 2014 and 15. If we look at the 2014, this is in the Yakima River Basin. 2015 is less greener than 2014. This is because of the drought and which impacted the water in that crops in that basin, and crops are less. Some regions are fallowed and crops are impacted due to low order, and those are not greener in that region. So what caused the 2015 drought? We have a lot of talk on this. I'm not gonna spend much time on this. So basically, the lack of snowpack because of the unusually warm winter, and it is considered as a wet drought because we had enough precipitation in the winter but not as a snow, which led into the snowpack drought. And also later in the summer we didn't have enough rainfall, so it has been a dry summer and not enough water from the precipitation during summer either. These 2 pictures are from the Olympic National Park, this April 2013 and 2015. You can see the difference, how much the snowpack reserve has been changed. So we don't have this snowpack during 2015. So we don't have this reserve to use this water later in the season whenever it is required. So the motivation for this study, are we going to have have similar kind of drought this year? we had a press release from Ecology which said that drought predicted to extend into second year, but is it going to be really bad, or it's going to be a moderate drought year? The right image is the NOAA's Climate Prediction Center's prediction for the whole US, and the northwest corner we see there will be a increased temperature during this winter. But if we look at the other two images in the left, we can observe that this is actually from NOAA's multimodal simulation, and the northwest corner in the Washington for October, November, December, the temperature is higher but not as much as compared to the January, February, March. So there will be increased temperature, but the impact will be most in the later in the winter, like in January, February, March here. So we are not expecting a warm winter, especially at the beginning of the winter. So we might have enough snow that which we can store it in the reservoirs later in the January, February months, when the water will be available from those snowpacks. Now, if this is going to be normal in the Pacific Northwest, we need to figure out how to deal with lack of snowpack while preserving our agriculture, drinking water, and other wildlife. And this is the reason we are doing this study, to develop an understanding of drought impacts on agriculture, useful for optimizing water management and developing adaptation strategies. There are basically two parts of our study. The part one, we are looking at how does the snowpack sensitivity to warming impact drought frequency and severity. And part two, science question, is how does the response of the crop vary under different cropping system and type of drought events. I am mostly focusing on the part one in this presentation. To look at basically I'm looking at the two types of drought events, two types of droughts. One is the meteorological drought, and another one is the snowpack drought, and look at their relative changes. For meteorological drought, I'm using Standard Precipitation Index (SPI), and for snowpack drought using Standardized Melt and Rainfall Index (SMRI). For SPI, precipitation used as input, and for SMRI, daily sum of snow melt and rain is used as rain is used as input. We using the snow melt obtained from the weak model output. So the data and models, 5 GCM downscale data has been used. The downscaling procedures is used the multivariate adaptive construction analysis, the MACA, which is developed in University of Idaho. I am using 5 GCMs downscale data. For historic years, we are using from 1980 to 2006, and for future 2007 to 2033. So both of them are 27 years for our comparison. And the scale is HAC 8 units. So hydrological unit number 8 has been used over the Pacific Northwest to look at all the index values. As the model, the variable infiltration capacity model has been used, from which the snow melt output has been used. It's the 116-degree resolution setup, and grid-based land. It represents a grid-based land surface system. So some of the results from some of the analysis. This is so whenever the SPI SMRI is less than 1.5, it is considered as a severe drought, and these are the drought frequency for historic and future scenarios. The yellows are the range for the future scenarios, and the blue lines are for the historic. The top one is for the meteorological drought, and all the x-axis is for all the Hawk numbers, and they are arranged from low to high snow precipitation ratio, which is based on historical data. For the meteorological drought, we see some places the observed data is within this range, but several of the Hawks is out of the range. So the meteorological drought has been observed to increase in some of the Hawk regions, but for the snowpack drought, it's higher than what we observed in the meteorological drought. So frequency of snowpack drought has been increased in more Hawk regions. And this is associated with whichever places the snowpack ratio went down. So wherever the snowpack ratio difference between the observed and the future scenario has been increased, it has been observed to increase in number of snowpack drought. This is the difference between the frequency of one month scale meteorological drought for the historic and the future climate scenarios for 27 years. So from this special distribution, we can see where the frequency has been increased, and for the meteorological drought, there has not been much correlation because all the results are showing kind of spread over this region, but for the snowpack droughts is pretty strong, and as we see there is like a triangular region in the Pacific Northwest where for all the GCMs has been showing increased number of snowpack droughts. So here the first row is the snowpack drought result that I have shown in the previous slide. The second row is the snow precipitation ratio. So it's the relative change of the snow precipitation ratio. And as we observe, the higher change in the snow precipitation ratio is in the Oregon region, is over the Cascades, and the central Washington and the eastern Washington are really noticeable. There is a trend that we can observe, and there is a resemblance between the percent of change in snow precipitation and increase in severe snowpack drought events. So here is the frequency of the two types of droughts averaged over all the Hawk numbers, and if you look at the snowpack drought, we see there is a shift in the number of snowpack droughts. So in the December, January, February, the GCM branch is containing the observed number of snowpack drought, but for March, April, May, June, July, for those summer and late spring months, there is a higher increase in the snowpack drought. This is because we are having less snow during the winter, so less amount of snow melt and rain during the summer months. And concluding remarks, these are the some results from the previous literatures that has been performed on the snow, the SUI data, and our results makes a close resemblance with these distributions. And this is the last slide that I'm talking about the future directions that we are working on. We are working on to find out the impact of these type of droughts on the agriculture, and the modeling system we are using a hydrologic and crop system model, VCropSIST, and a reservoir system modeling called SIM. And so we are trying to simulate the water and crop management. So the significant part work is required for the middle part, where we need to know about how all the management decisions are needed made in the field during the drought season. That's why we're doing some field surveys and getting some historical records from all the state agencies. And next, the impact analysis. That's it. Thank you.
Well, Mohammed finished in plenty of time, so we have lots and lots of time for questions. Paul.
Your map with the little red dots
Right.
was showing one of these. That southwest area is west of the Cascades, and it's not an area that gets much snow. So I was kind of wondering how you incorporate snowpack drought in an area that doesn't.
Actually, this is based on the snow melt and rain. So both are in that together. So both impacts are considered. So if you are not having much snow, rain will be dominated in
Is
that
the
index.
southernmost basin the Rogue? Or is it the Klamath? Looks like the Rogue.
Yeah.
So I think those basins do actually have a snowball component, the Rogue and the Umpqua.
So is it like there's very little snow, so it goes to zero, and that's a really high percentage change? Is that?
There's more snow in those basins than in the Willamette, I think, Dan.
Yeah, I mean,
Yeah, that's part of the stuff. I mean, it's hard
yeah,
to see
both
this,
both of
Yeah.
yeah, but here that one is relative. Those are not relative. This is like relative to the snow precipitation ratio change. So you can actually see how much of the ratio has been changed compared to the historic snow precipitation ratio. So if there is no snow, I wouldn't have any kind of dots there. So it shouldn't have any dots. So if the dot is there, there is snow.
It's just-
But not much.
Are the metrics based on the stream hydrology, or the metrics based on the actual precipitation metrics?
It's based on the precipitation, but it's standardized. The index. Are you talking about the meteorological index or drought index?
It's not based on gauged flows, it's based
No,
on the
no,
actual
no.
precipitation.
That's yeah. We have. I mean, if we consider hydrological drought, then yeah, you look at the stream flows and consider that yeah, hydrological drought. But we might consider that later in the study. But you can use the same index to prepare. Look at the hydrological drought. Sure.
I have a two-part question. What crop species are you going to be modeling? And the second part is, how are you going to do that?
So basically, we are almost looking at all the major crops, and almost all the crops that's in the WSD database or is in the crop database, like the CDL, and we'll consider that. And how we are going to do that?
But are you talking about just like cereal crops, or are you also doing like apples, tree crops?
all kind of crops, like high value crops, small value crops, grains, and cereal, this kind of. And yeah, we are using this couple modeling system, the CropSys, and yeah, the V takes care of the hydrologic part, and CropSys is a field level crop model, and it has its own parameters for growing crops and give you the yield.
Still time for more questions? Well, I have one. How did you choose the 5 climate models that you used?
That's really random, but we have to. I mean,
Alphabetical order looked like roughly.
yeah, I mean there are ways to choose the climate model. There are several indexes on that, but I'll be looking into more to include more to have the whole range. To look at the range of uncertainty from the climate model. But this is just some reference.
Any other questions? Going once? Twice. Okay, thank you.
Thank you.